Welcome to another edition of Solving Hard SAT Math Problems using Desmos. Desmos is a very powerful tool that, when used correctly, can save a lot of time and effort when solving the SAT math portion. So the first problem that we're going to deal with involves two linear equations. And we're asked for each real number r, which of the following points lies on the graph of each equation in the xy plane for the given system. I've already inputted the two equations. You can see, as you can see, the second equation is just 3 times the first equation. So the two equations are identical to each other. And you can see that the first equation is the green line, and when I turn on the second equation, it overlays on top of that and becomes the purple line. I've gone ahead and input the options here. When the only variables that Desmos allows is x and y, and when you put in any other letter or alphabet here, in this case r, it'll ask you to add a slider. A slider just means that you can adjust the values of r when you click this button. So when we click this button, it allows you now to adjust the values of r. We are given here that r can be any real number. So when we move the slider around, we can see that options A, B, C, and D move around. But the only option that stays on the purple line, which is the second equation, is option A. Okay, you can see that option B, C, and D do not stay with the purple line itself. And so this means that A is the correct answer in this situation. The second problem deals with a couple of inequalities, and we're asked to find the y coordinates of all the points that satisfy the system of inequalities above. Okay. Again, we'll use Desmos, and you'll see that life becomes much easier. So we'll input the first equation, y is greater than 2x minus 1. And the green shaded region satisfies this inequality. And the second one is going to be 2x is greater than 5. Sorry, 2x is greater than 5 here. And the purple region satisfies the second inequality. And the actual combination of both inequalities is this darker shaded purple, which overlaps the green and the purple. And you can see that the point above this, which is the two shades of green and purple, is going to be y is greater than 4. So any point above this satisfies both equations, which means that y has to be greater than 4 for it to work, which means that the answer is going to be B, y is greater than 4. The third problem is a bit different. Here we're going to use a feature of Desmos called regression to try to solve this problem instead of using the graphs. Okay, so we're given this function, which is looks like a exponential function, and we're trying to find the value of b given that a and b are constants. So the first thing that we got to do is use something called a table, which is part of Desmos. So we will start off by typing in table, and when we type in table, automatically the table comes up. And what you want to put in the table are the two intercepts, right? So the first intercept is going to be the x-intercept, so it's going to be 2, 0. And then the next set of points is going to be the y-intercept, which is going to be 0, negative 323. Okay. There's a reason we do that, because for regression, we need at least two values in this table. And now we don't use a function f of x equals a to the x plus b, or y equals a to the x plus b. But since the value of the tables are x1 and y1, we will use y1, and we won't use the equal to sign, but we'll use the tilde sign here, is going to equals, or this tilde, a to the power. Again, we don't use x, we use x1 because those are the variables given in the table above. And then we say plus b. Okay. So when you input the function this way, you can see that this in the statistics bars, r square is 1 and r is 1. You don't worry about that one. But the real numbers that we need are a and b, which is in the parameters section. So you can see that a here is 18. And more importantly, what's being asked is b, and b is going to be equal to negative 324. So another powerful way for Desmos to help us solve this seemingly difficult problem. In this problem, we'll use regression again to find the answer. So here we're given the function p of x, where c is a constant, and we're given that p of c is 10, and we have to find the value of p of 12. So the best way forward is to just plug in c where x is. Okay, so we'll say this is c minus c the whole square, or the whole square, plus 160 all divided by 2c. Okay, now we're not going to make it equal to 10, but again, we'll use the tilde sign, and we will make the right side 10. Okay, and as you can see, the value of the letter c is given as 8. Okay, now Desmos is smart, and it saves the value of c as 8 already, so we don't have to put in 8 wherever c comes. Okay, so now we're trying to find the value of p of 12, and now we're gonna just replace the x with 12 in the equation, and so we're gonna say 12 minus c the whole square plus 160 all divided by 2c. Okay, and as you can see, the answer is 11, which is option D. Our last problem deals with an absolute value. Here, all we need to do is put in these two equations in Desmos, and we'll see where they come together, and that'll be the answer. Okay, so we can say f of x is going to be equal to, for putting the absolute value, we start with ABS, and then parentheses 59 minus 2x. Okay, that's our blue line right here. And then the next one that we can do is we can actually put in k as a variable as well, and f of k is going to be equal to 3k. Okay, and that's given by the line, the green line. Okay, and as you can see, these two graphs intersect each other at 11.8 comma 35.4. Okay, and we need to find what the value of k is, so that'll be the first part of the coordinate, or the x coordinate. Okay, and we're given this as 11.8, which is a decimal number, but all our options are fractions. Okay, An easy way to do this, to convert 11.8 to fractions, is just putting 11.8 in here. And you can see on the left, right below the number 3, where my pointer is an icon. And when we click that icon, it makes this decimal number into a fraction. And this fraction comes out to be 59/5, which is option A. And that's your answer.